Dear students, today's our topic is real numbers. In the real numbers, we have various types of numbers already well learned in the classes. So already you know that one. So the first type is, what are those? Natural numbers. So numbers which are useful to count the space 1, 2, 3, 4 like that. So these numbers are generally denoted by capital N, then 1, 2, 3, 4 up to so on. Next, second type, whole numbers, and these are simply natural numbers including 0. 0, 1, 2, 3, 4 up to so on. Okay. The third type, integers. So these are also weird. So these integers are generally denoted by I or Z. So these numbers can be written as -3, -2, -1, 0. Actually these are left side to 0 and +1, +2, +3 on right side to 0. That means the whole numbers including negative numbers are known as integers. Okay, so these are denoted by I or Z. And next, rational numbers. Rational numbers means a number which can be represented in the form of P by Q and Q not equal to 0 and P and Q are integers. Okay. And one more type for also there, the rational numbers. Now in this chapter we will discuss that numbers in that form. So till these 4 type numbers, the first type numbers 1, 2, 3, 4 are can be represented on a number 1. And moreover, each type of numbers can be put in the form of P by Q. For example, I am taking an integer -14. That means here -14 can be written as -14 by 1. Not only -14, you can take any other type of number, for example 2. So that can be written as 2 by 1, 3, 3 by 1. That means every number, each and every number can be put in the form of P by Q. That is, there here, every particular is -14. In -14 by 1, here P is -14 and Q is 1. Okay, and now Q must not equal to 0. We have to that point. And now by represent these type of numbers, you can draw a line and look at that numbers on a line. So, but whereas in rational numbers, let us take for example 1 by 2. So we have so many equivalent fractions to this 1 by 2. For example, 2 by 4, and next 3 by 6. So like this you can get so many type of numbers equivalent to this 1 by 2. So many type of equivalent fractions. That means here this P by Q representation is not a unique. That means rational numbers does not have a unique representation. So for that purpose, we have to define, once again define the P by Q, the rational numbers which are in the form of P by Q. We can define in alternate way. So how can we define? Here a number which is in the form of P by Q and Q not equal to 0, and next P and Q are having the universal factor 1. That is universal common factor 1. Okay. So or otherwise we can say P and Q are co-primes. So a rational number can be defined as a number which is in the form of P by Q, Q not equal to 0, and P and Q are co-primes. Co-primes means they must have only universal factor 1, common factor 1. So prime numbers, 4 prime numbers here, P and Q are 4 prime numbers. Okay. So now on number line, we can represent maximum numbers, whole numbers, and integers very easily. Okay, let us recall those representation on number lines. So for example, I am taking first of all whole numbers. Okay, so how can we represent whole numbers on number line? So first, we have to draw a line. First, we have to draw a line. Okay, and next make a point on that line 0 and take the equidistances from 0. Locate other numbers. Okay, now 1, 2, 3, 4, which are equidistant. Okay, and now these are the whole numbers, representation of the whole numbers. Whereas integers, these can be represented on a number line. First draw a line and make a point on point 0 and take equidistances like this. Now locate first of all equidistances like this and point out 0, 1, 2, 3, 4. Okay. So on right side to 0 we can locate first numbers as you know up to so on. And next on left side we have to take the negative numbers on equidistances. So like this we can represent integers on number line. Whereas rational numbers, how can we represent rational numbers on a number line? Okay, do you remember? Already we did this type of representation of rational numbers in 8th class. Okay, for example I am taking a rational number 3 by 4. So first represent 3 by 4 in pictorial. Okay, so first I am taking historical as 1 unit, and this 1 unit can be divided into 4 equal parts. So from these 4 equal parts I am selecting 3 parts. That means these 3 shaded regions represented by 3 by 4. So this is a pictorial way. Otherwise we can see this rectangle shape also. I am taking this rectangle shape as 1 unit and make it is into 4 equal parts. So again, among these 4 equal parts, I can pick up 3. That means I am shaded 3 parts. So that's why this represents 3 by 4. These 2 are what? In the form of pictorial. Whereas in number line, that is the main thing here. Okay, so how can we denote or represent 3 by 4 on a number line? Okay, for that also we need first of all a line. First of all, draw a line. So after drawing a line, first of all you have to look at 0 or make a point a line and represent it as a 0. On right side take 1. Okay, and we need here 3 by 4. That means we have here on denominator 4. Okay, as you know already we use the numerator, 4 is the denominator. So on denominator we have 4. So that's why here 0 to 1 again it is a 1 unit. So take this as 1 unit and make it into 4 equal parts. That means they have to keep the equidistance points. That is, they have to take 1, 2, 3 and then like this. That means till here, here to here and here to here and here to here. So how many equal parts we have? Assume it as 4 equal parts. So among these, each part is taken as 4 upon 1, that is 1/4. First one is 1/4 from 0. From 0 to this second dot, 2/4. From 0 to this dot, 3/4. From 0 to this fourth one, that means that one can be written as what? 4/4. So like this we can represent 3/4 on one number line. Okay, so like this we can represent any number. That means we have to observe first of all the denominator. Okay, so by the denominator we have to equate or divide each unit into that number of denominator value. Okay, so here I am taking one more example, 5/3 representing 5/3. I am taking other minus fraction, also minus 5/3 on a number line. Okay. And again draw a line here. Keep 0, make a point on that 0, and now again select the 1 on that, and again. Okay, why I am taking up to 2? Let us see. Now first of all, equate 0 to 1, that is that 1 unit, into 3 equal parts. Okay, divide it into 3 equal parts. For that we need here just 2 points. 1, 2, 3. So here it is 3 parts. Among them, first one select as 1/3. That is 0 to the first point is 1/3. It stands for 1/3. And next 0 to this second point, 2/3. And again that one can be written as 3/3. And again that 0 to 2 we can write 2 more fractions as after 3/3 you can write 3/3. And next this part is taken as what? After 3/3 you can write immediately 4/3. And next after 4/3 you can write 5/3. And after 5/3 this 2 you can reach, that is 6/3. On right side we are getting plus 5/3, that is right side to 0, we are getting 5/3. In the same way select minus 5/3. Now point out minus 5/3 on left side to 0. For that again we need here -1 and -2. Okay, so now again 0 to -1, divide it into 3 equal parts. So select 2 more dots on the left side to 0, which are equidistant. So now here first this 0 left side 0 first left side point is taken as -1/3, and the next point is -2/3, and the -1 is written as -3/3. After that you can easily write like this again, -1 to -2 we have again we have to divide into 3 equal parts. So that's why here this minus after -1, that is after -3/3, we may get -4/3, and again that -5. So like that you can represent easily this -5/3 on number line. Okay. So how did you write these units on number line? So first you see this 5/3. So in this 5 already we have 3. So that's why we can write it as 3 plus 2/3. Then we can write it as 3/3 plus 2/3. That is 3/3 means 1 plus 2/3. It is more than 1. Nothing but it is more than 1. That means it is an improper fraction. Okay. So improper fraction means if the numerator value is greater than that of the denominator, then we can say it has an improper fraction. We know that all improper fractions are greater than 1. So that's why it takes that 5/3 is represented after 1 unit. That's why I am taking on 2 units on 2 units right side to 0 and 2 units on left side to 0. Okay, so to represent that 5/3, and each unit is selected divided as into 3 equal parts. Okay. So by that way we can represent this pi by 3 and minus pi by 3 in n. Let us see more sums next.